Dear students, in this video we are going to discuss about the topic coordinate covalent bond. What is that? Coordinate covalent bond. Okay students, first do you know how covalent bond is formed? Yes, covalent bond is formed by mutual sharing of electrons between the atoms. How the covalent bond is formed? It is formed by mutual sharing of electrons between the atoms, and the formation of covalent, each atom contribute one electron to form a covalent bond. And in the formation of an atom, each atom contribute one electron and that forms the covalent bond. Now let us see what is coordinate covalent bond. Formation of some covalent bond take place by sharing electrons which come from only one combining atoms. What is that? Formation of covalent bond between two atoms take place by the sharing of two electrons, both of which comes from only one of the combining atom. So this is called as coordinate covalent bond or dating bond. That is shared pair of electrons. It is combining and it is coming from a single atom. ஒரே ஒரு ஆட்டம்ல இருந்து கம்பைன் ஆகி வரக்கூடிய ஒரு எலக்ட்ரான். That is only we will call as coordinate covalent bond. Formation of some covalent bond take place by sharing of electron which come from only one of combining atom. இப்போ ரெண்டு எலக்ட்ரான் வந்து ஒரு ஆட்டம்ல கம்பைன் ஆயிருக்குன்னா அந்த ஒரு ஆட்டம்ல இருந்து கம்பைன் ஆகி வரக்கூடிய எலக்ட்ரான்ஸ் தான் we will call as coordinate covalent bond or dative bond. Most of the lone pair of electrons of an atom involved in the formation of coordinate covalent bond. In coordinate covalent bond, most of the lone pair electrons are involved. Lone pair electrons means without the electrons that are getting paired. The pair of electron which do not involve in bond formation is called as lone pair of electrons. பாண்ட் ஃபார்மேஷன்லேயே இன்க்ளூட் ஆகாமல் ஒரு சில எலக்ட்ரான்ஸ் வந்து தனியாக இருக்கும். அப்படி இருக்கக்கூடியதான் வந்து இட் இஸ் செட் டு பி ஆஸ் lone pair of electron. So in coordinate covalent bond, most of the lone pair of electrons are accommodating. Okay, now let us see some with examples. See here, first example is NH3. NH3 is ammonia molecule. NH3 is ammonia molecule. What is atomic number of nitrogen? Nitrogen atomic number is 7. So its electronic configuration is 2,5. One nitrogen atom is combining with 3 hydrogen atom. So what is the atomic number of hydrogen? Its atomic number of hydrogen is 1 and its electronic configuration is also 1. So now nitrogen atom is combining with hydrogen atom and forming a coordinate covalent bond. Let us see how it is forming. So what is the electronic configuration of nitrogen? Nitrogen electronic configuration is 2,5. So we want to take the valence electron. How we want to represent the 5 dots? 1, 2, 3, 4. Now where we want to place the fifth dot? Near the first electron. So here how many shared pair of electrons? Here it is having only one shared pair of electron. How many unpaired electrons are there? 3 unpaired electrons are there. 3 unpaired electron and only one electron is paired. Now let us do for hydrogen. See here, nitrogen atom 1. It is getting paired. Next it is combining with hydrogen atom. Hydrogen atom, for how many hydrogen atom? 3 hydrogen atom. So 3 hydrogen atom is having 1 electrons. So now what it is doing means it is getting nitrogen and hydrogen. Nitrogen is having 5 electrons and hydrogen is having 3 electrons. Now nitrogen and hydrogen are getting combining together and it is forming the coordinate covalent bond. So to attain the stable electronic configuration, nitrogen need how many electrons? Already it is having 5 electrons in their valence shell. To attain the stable electronic configuration, it want 3 more electrons. So what it is doing means hydrogen is sharing the electrons. It is not hydrogen is donating the electrons to nitrogen atom and it is forming a bond. Now let us see here. After donating it, nitrogen 1, 2, 3, 4, 5. While it is combining with hydrogen atom, how many electrons are there? 3 electrons are there. So Now these all are combining with hydrogen atom. இதெல்லாம் என்ன பண்ணுது? 3 hydrogen atom is combining with nitrogen atom and it is attaining a stable electronic configuration. Now you count how many electrons are there? 1, 2, 3, 4, 5, 6, 7, 8. It is having 8 electrons in their outermost cell. So it attained a stable electronic configuration. Now here nitrogen atom, it is not including in the bond formation. So it is a lone pair. All these electrons are included in the bond formation. So it is a bond pair. If the pair of electron, it doesn't included in the bond formation means that is said to be as lone pair. Here these two electrons are not included in the bond pair. So it is said to be as lone pair. These three pair of electrons are included in the bond pair. So it is said to be as bond pair of electron. So nitrogen outermost shell having how many electrons? It is having 8 electrons. The pair of electron which do not involve in the bond formation is called as lone pair of electron. So NH3, how we can represent the NH3? N bond H, bond H, bond H. It is having 2 lone pair electrons. So we can represent NH3 by using single bond. Here why we have put single lines? Because it is a single pair of electrons. So here we have represented it by single lines. Are you clear? Now look at the next example. BF3. BF3 is boron trifluoride. What is BF3? Boron trifluoride. One boron atom is combining with 3 fluoride atom. One boron atom is combining with 3 fluorine atom and it is forming a boron trifluoride. What is the atomic number of boron? Boron atomic number is 5. So its electronic configuration is 2, 3. Fluorine atomic number is 9. So its electronic configuration is 2, 7. So boron to attain the stable electronic configuration, it wants how many electron? It need 5 electron. But fluorine to attain the stable electronic configuration, it need only 1 electron. Now let us represent, see here, boron electronic configuration is 3. And the fluorine atom, how many fluorine atom are there? BF3. So totally there are 3 fluorine atom. What is the electronic configuration of fluorine atom? 2, 7. Its valence electron is 7. So here first 1, 2, 3, 4, 5, 6, 7. So here how many shared pair of electrons are there in the fluorine atom? There are 3 shared pair of electrons. 3 shared pair of electrons are there in the fluorine atom. Only 1 is not shared. Now let us see how. To attain the stable electronic configuration, fluorine need 1 electron. So totally there are 3 fluorine atom. So what the boron atom is doing means it is sharing the electrons. It is sharing 1 electron. This 1 electron is sharing to this fluorine atom. This 1 electron is sharing to next fluorine atom. And this 1 electron is sharing to next fluorine atom. Totally there are 3 fluorine atom. So boron is sharing 1 electrons to 3 fluorine atom. After sharing, see here, boron 1, 2, 3 arm. 1, 2, 3. This is the boron electronic configuration. Now fluorine atom. What the fluorine atom is doing means, fluorine atom is sharing the electrons. See here, fluorine atom. Boron atom, boron shared 3 electrons to fluorine atom. Already what is the electronic configuration of fluorine atom? 2, 7. So its outermost cell having 7 electrons. Now boron shared 1 electron. So it is having 8 electrons in their valence cell. It is obtaining a stable electronic configuration. See here, 1, 2, 3, 4, 5, 6, 7. Here 1, 2, 3, 4, 5, 6, 7. Here also 1, 2, 3, 4, 5, 6, 7. So, how is this? See here, boron atom shared 3 electrons to fluorine atom. So, fluorine atom forms a stable electronic configuration. Now, we can represent this by BF3. We can write by boron, fluorine, and fluorine atom. Why it is represented by single electron? Because it shared only single pair of electrons. So it is represented by single bond. Now let us see with the coordinate covalent bond. Now we are combining ammonia molecule and boron trifluoride in a coordinate covalent bond. Illustration 1, that is formation of coordinate covalent bond between NH3 and BF3 molecules. Now see here, NH3 is, we can represent this by N bond H and bond H. It is having two lone pair of electrons plus boron trifluoride. So BF, it shared three single pair of electrons. So here we are having three triple bonds. Now what it is doing means it is donating, because while sharing its octet configuration getting disturbed. What it is doing means, already what is the fluorine atom electronic configuration? 2,7. If it shared 3 electrons means its electronic configuration will be 2,8. So it is getting confusing in stable electronic configuration. So what the ammonia molecule is doing means, these two electron, it is donating to the boron trifluoride. Ammonia atom is donating 2 electrons to boron trifluoride. So the atom which donates electrons are called as donator, and the atom which accept the electrons are called as acceptor. So here the ammonia atom is donating and providing the electron to the boron atom. So here ammonia atom is a donator atom, and here the boron trifluoride is an acceptor atom, because it accepts 2 electrons from the ammonia molecule. So here it is an acceptor atom. See here, nitrogen is providing electron to boron. So nitrogen is a donor atom, boron is an acceptor atom. Now let us see the schematic representation. See here, after donating 2 electrons, it becomes nitrogen, single bond hydrogen, and single bond hydrogen. Here, for coordinate covalent bond, we are representing by arrow mark. But in covalent bond, if there is a single pair of electrons means we will represent by single lines. If it is a double pair of electrons means we will represent by double line. If it is a triple pair of electrons means we will represent by triple line. Here, for coordinate covalent bond, we are representing by arrow mark. The atom that donates, in the atom, the coordinate bond is represented by arrow mark from the point from donor to acceptor. Here nitrogen is the donor atom. So we are starting the arrow mark with nitrogen. Next to boron is boron trifluoride. F. So here boron is combined with nitrogen ammonia molecule. So its form will be NH3. We need to represent it by arrow mark. So BF3. That is ammonia molecule is ammonia molecule has a coordinate covalent bond with boron trifluoride. Because if it shared 2 electrons means its stable electronic configuration will get confused. So what the ammonia atom is doing? Ammonia atom is donating 2 electrons to the boron trifluoride, and it becomes as a donor atom. The boron trifluoride accept the 2 electron, so it becomes as an acceptor atom. Are you clear? So here in the coordinate covalent bond, we are representing by arrow mark. The atom that donates the electron, the arrow mark should start from donator to acceptor. Okay, what is coordinate covalent bond? Formation of some covalent bond take place by sharing of electron which come from only one of combining atom. This type of bond is called coordinate covalent bond. In this example also, nitrogen has combined and it is giving, after combining the atom, it is donating, it is sharing the electrons. So it is a coordinate covalent bond. Coordinate covalent bond is represented by the arrow mark. Are you clear?